First observation: star survives black hole encounter and returns. This groundbreaking discovery challenges everything we thought we knew about black holes and stars. Imagine a star daring to venture too close to a cosmic monster, only to survive, get shredded, and return for another visit. That's exactly what happened with a star observed by an Israeli-led team, marking the first time such a phenomenon has been confirmed in history. But here's where it gets controversial. What does this mean for our understanding of black holes and the universe's most violent events? A team from Tel Aviv University, including astronomers like Dr. Lydia Makryani and Professor Yair Arkavi, captured two dramatic light flashes from the same location in space, named at 2022 DBL. The first flash occurred when the star was torn apart by a supermassive black hole, but 2 years later, a nearly identical flash was detected. This suggests the star wasn't completely destroyed. It survived, parts were flung back into space, and it made a second pass. The discovery forces scientists to rethink long-standing theories about how stars interact with these cosmic giants. Supermassive black holes, found at the centers of galaxies, are so massive they warp space and time. Their gravitational pull is so strong that even light can't escape. While we've studied these monsters for decades, their behavior during star encounters remains mysterious. The Milky Way's central black hole, which earned a Nobel Prize in physics, is just one example of these enigmatic entities. Yet, how they form and how they shape galaxies remain unanswered questions. The process of a star being torn apart by a black hole is called a tidal disruption event. When a star approaches too closely, its own gravity struggles to hold it together, and the black hole's immense pull stretches the star into a thin, glowing stream. Most of the star's material spirals into the black hole, but sometimes, like in this case, part of it is ejected. The team's findings suggest this star may have been partially consumed, with only half of it surviving to return for another encounter. As Professor Arkavi put it, this is more like the black hole taking a nibble than a full meal. The mystery deepens. Could there be a third flash in early 2026? If so, it would mean the star underwent another partial disruption. If not, the second flash might have signaled a complete destruction. This raises a critical question. What if the flashes we've studied for years aren't what we think they are? Some scientists, like Professor Tzvi Piron's team, argue that partial and full disruptions might look almost identical, blurring the line between the two scenarios. So, what does this mean for our understanding of the universe? It means we need to re-examine every observation, every flash of light, and every theory about black holes. The cosmos is full of surprises, and this discovery reminds us that even the most extreme events can defy our expectations. What will you think when you hear the answer? Let us know in the comments. What if the second flash wasn't a complete destruction? And what if the third one is the key to unlocking the secrets of these cosmic giants? Star survives black hole encounter. First ever repeating tidal disruption event discovered. Imagine this. A star, after facing the immense gravitational pull of a black hole, not only survives but comes back for a second round. Sounds like science fiction, right? But here's where it gets even more fascinating. Scientists have actually witnessed this cosmic dance unfold. For the first time ever, astronomers have observed a star enduring a close encounter with a supermassive black hole, escaping destruction, and then returning 2 years later to create a nearly identical flare. This groundbreaking discovery is challenging long-held assumptions about how stars interact with black holes and could rewrite parts of astrophysics as we know it. The story begins with an international team of researchers led by Tel Aviv University astronomers Dr. Lydia Makryani and Professor Yair Arkavi. Their findings, published in the Astrophysical Journal Letters, detail the unprecedented observation of what's known as a repeating tidal disruption event, TD. A TD occurs when a star ventures too close to a black hole, leading to its partial or total obliteration. In this case, however, the star wasn't completely destroyed during its first brush with the black hole. Instead, the black hole only partially disrupted the star, allowing it to escape, for now. 2 years later, the star returned, creating another flare almost identical to the first. This raises some intriguing questions. Could this mean that similar events in the past were misinterpreted as total disruptions when they might have been partial ones? And this is the part most people miss. If the star returns again around 2026, as the researchers predict it might, it could provide definitive proof of the partial disruption model. Such an observation would force scientists to rethink how black holes feed on stars and how these interactions influence the evolution of galaxies. Now, let's break down why this matters. At the heart of nearly every large galaxy lies a supermassive black hole, often millions or even billions of times the mass of our Sun. Our own Milky Way is no exception, housing Sagittarius A*, the supermassive black hole, at its core. While we understand that these cosmic giants exist, their role in shaping galaxies remains a mystery. One way scientists study them is by observing rare instances where a star wanders too close to a black hole and gets torn apart, a process that releases a tremendous amount of energy, creating a luminous flare visible across vast distances. When a black hole consumes a star, the material doesn't just vanish. Instead, it swirls around the black hole in a disk-like structure, accelerating to near-light speeds and emitting intense radiation. This glowing beacon serves as a signal to astronomers that something extraordinary is happening. However, these flares don't always behave as expected. For instance, the brightness and temperature of at 2022 dBl, the flare observed in this study, were far lower than models predicted. Why? The answer may lie in the fact that the black hole didn't fully devour the star during either encounter, leaving enough material intact for a repeat performance. Think of it like a buffet line. The black hole grabs a bite during the first pass, but instead of finishing the meal, it lets the star slip away temporarily. When the star loops back around, the black hole takes another helping, but still doesn't finish it off. Will there be a third pass? That's the million-dollar question. If a third flare does occur, it would confirm the partial disruption model and suggest that many previously observed TDs might also have been partial disruptions rather than total annihilations. On the other hand, if no third flare appears, it could mean the second encounter marked the star's final demise. Either outcome will require scientists to revise their understanding of these events and the insights they provide into black hole behavior. So what do you think? Is this evidence of a pattern we've overlooked? Or are we witnessing a truly unique cosmic phenomenon? Let us know your thoughts in the comments below. After all, discoveries like this remind us just how much we still have to learn about the universe. And isn't that the most exciting part?